Hello everyone, and welcome to our lesson on the anatomy of a neural network. Today we'll be diving into the fundamental components that make up these powerful machine learning models. First, let's talk about the building blocks of deep learning. Layers. Neural networks are essentially stacks of these layers, each transforming the data and passing it along. We have the input layer, which is where raw data enters the network. Then come the hidden layers, which perform all the complex calculations. Finally, the output layer gives us the network's result. There are different types of layers. Dense or fully connected layers connect every neuron in one layer to every neuron in the next. Their operation can be described by the equation y equals sigma of w times x plus b, where w is the weight matrix, x is the input vector, b is the bias vector, and sigma is the activation function. Convolutional layers are great for grid-like data, like images, using filters to process them. Recurrent layers are designed for sequences, like text or time series, and have internal memory. Activation functions are crucial because they introduce nonlinearity, allowing the network to learn complex patterns. Some common ones are ReLU, which is the maximum of 0 and x, sigmoid, which squashes values between 0 and 1, and tanh, which squashes values between -1 and 1. Here's a quick code example demonstrating a simple dense layer using TensorFlow and Keras. We import the necessary libraries, create a dense layer with 10 units, and ReLU activation, generate some dummy input, and pass it through the layer. The output shows the shapes of the input and output data and the output data itself. Note the user warning about input shape, which is common when using sequential models. Next, let's look at how layers form models. A neural network model is created by stacking layers. Sequential models arrange layers linearly, with the output of one layer feeding into the next. Functional API models offer more flexibility for complex architectures. Here's a code example of a sequential model. We create a sequential model and add 2 dense layers with ReLU activation and an output dense layer with softmax activation for classification. The model summary shows the layers, output shapes, and the number of parameters. Training a neural network involves loss functions and optimizers. The loss function measures how far off our predictions are from the actual values, and our goal is to minimize this loss. Common loss functions include mean squared error for regression, categorical cross entropy for multi-class classification, and binary cross entropy for binary classification. The optimizer is the algorithm that adjusts the network's weights and biases to reduce the loss. Examples include stochastic gradient descent, ATOM, and RMS-prop. Here's a code example of compiling a model. We take the sequential model we just created and compile it using the ATOM optimizer, categorical cross entropy loss, and accuracy as a metric. In summary, we've covered the core components of a neural network: layers, models, loss functions, and optimizers. Understanding these building blocks is key to building effective neural networks. We touched upon different layer types, activation functions, model architectures, loss functions, and optimizers. This was a basic introduction, and there's much more to explore in this field. That concludes our lesson on the anatomy of a neural network. Thank you for joining.